Problem solving, finding unknown sides. There are many applications for trigonometry. I have drawn on the board a telecommunication tower. Let's look at this video and think if you had to construct this tower. You are to design this tower. It is 340 feet high and the angle is 83 degrees. What is the length of the sides of the tower? Let's do the math. The height of the tower is 340 feet, and we want to find this length of this side. So if we draw a line from here down, that would be a right triangle. And so this is 340 feet, and that would be opposite from this known angle. And this obviously is the hypotenuse. So what we want to find out is what is x, or this hypotenuse. And so we have the opposite and hypotenuse. So we look here to SOHCAHTOA, and that would be this formula. Sine of 83 degrees equals opposite, and that's 340, divided by the hypotenuse, which is the unknown, x. So let's do the math and cross multiply. So 340 equals sine of 83 degrees times x. Divide each side by sine 83. This will cancel out. So x equals 340 divided by sine of 83. Let's go to the calculator. So 340 divided by sine of 83 equals, so it's 342.55. So x equals 342.55 feet. So the length of this side of this tower is 342.55 feet. Chris Jarrell, Customer Support Engineer for Mitsubishi EDM, will teach how trig is used. But before he does that, I want to explain a little bit what EDM stands for. It stands for Electrical Discharge Machining. And here's how it works over here. This is a part. Any kind of material that conducts electricity can be cut with electrical discharge machining. And if you want more information, by the way, you can go to www.reliableedm.com. I happen to be the president and owner of this company, and we have over 50 EDM machines, and we're the largest company of this kind west of the Mississippi River. So if you want to learn a lot more, just go to this website. So any conductive material, even tungsten carbide, can be cut. This is a wire. We generally use a wire about 0.012 thick, round. It's about 12 thousandths. But also you can cut 10 and 8 and 6 and 4 and even thinner than that. And what happens then, sparks from the wire, it works through spark erosion, jumps from here to the part and erodes. So with the wire, what happens is this here. This is the wire, and let's say it's cutting apart. And then the spark jumps across here and melts part of the wire and part of the workpiece. Now this wire, if it touches the workpiece, is a short circuit. So there's a servo mechanism that maintains that gap. And we can cut to accuracies, all right, plus or minus 0.0001. And to give an idea how close that is, let's look at a human hair. Human hair is approximately 0.002 thousandths thick. And some people, oh boy, that's really close. Well, to give you an idea of what 0.0001 is, it's 1/20th of a human hair. That's how close we can cut. So it's an extremely accurate procedure, electrical discharge machining. And we do work all around the United States, and we have different customers. And this is what it cuts with. This is the wire. This is the wire. It's a piece of brass wire. And we can cut in all kinds of angles. Not only straight, we can cut up to 45 degrees. And if you're going to cut, you have to use trigonometry. And here's some parts. Here's a part that was cut at 45 degrees. So as you can see here, this is the bottom of it. You can see how it was cut. Here's another part that was cut. I don't know what this was used for, but it was cut on EDM. You can see some sharp blades here. Looks like some kind of a knife that was being cut. Here's a part we do a lot of work for oil field work. And this comes off of here. You can see the parts here, how it looks on the bottom. And this all has to be programmed with EDM. Everything has to be done mathematically. Every shape, angle, math, algebra, geometry, trig. We live off of that. Now here's the example that you can understand. And here's the bottom. This is a mold. The plastic comes in here. And this is the shape that comes out. And so we put a hole in there. That's where the wire goes through. It's like a precision bandsaw. We put the wire through. You can see the kerf. This is the kerf over here. That's where that's the path of the wire. So this is actually the scrap part. And so this gives you a little bit idea. And this is the shape that comes out of this extrusion mold. As you can see, this is an exceeding precision type of operation that we do. We do also rough cuts. And now let's listen to Chris Jarrell as he explains to us the EDM process.
A lot of wire EDM applications, when people are doing a lot of form tools or some sort of a cutting tool, instead of cutting with an actual taper angle called up in the program, what they like to do is they pre-tip the wire to a locked position for the entire contour of the shape that they need to cut. So in an application like we have our two upper and lower flush cups, I'm going to need to wind up tipping these things to a pre-tipped angle and locking them in that position for the entire burn that we do. Okay, so what I need to calculate is how much movement is going to be required in that U or V to meet the angle that I need to cut at. So what we have on both upper and lower heads will be a flush cup, and inside that flush cup is the actual diamond guide. And in the very top of this diamond guide, there is a ceramic cone where the wire pivots back and forth. Well, it's the pivot points of these diamond guides that I need to know the span between in the upper and lower, because this diamond guide is inserted inside the upper flush cup assembly. Okay. Once I know these two values, what the machine is going to tell me what they are, what I can now do is I can now trig out the amount of movement needed to tip over whatever specified amount to meet the angle that I need to cut at. So let's say for this particular example that the upper and lower constants, or the gaps between these diamond guides and cups, are each 300 thousandths. So if each of these here are 300 thousandths, what I now need to do is I'll take the total guide span between upper to lower diamond guide and multiply it by the tangent of the required angle that the wire needs to be tipped. So if my job is requiring 5 degrees of taper, what I'm going to do is take this total guide span of the head height of 4 inches plus the 300 thou and 300 thou for each constant will give me a total guide span of 4.6, and I'm going to multiply that by the tangent of the required angle that my wire needs to tip. So it would be the tangent of 5 degrees. So if I take the tangent of 5 degrees multiplied by the guide span, that is going to come out to equal a value of 0.4022 inches. So what I can do in the beginning of our programs is, by performing this calculation, is telling the machine to move that U or V axis, that specified amount, to be tipped at the proper angle needed for a cut.
Keep up the good work. After completing the problems on this page, take the test. And don't forget, double check your work. We have also provided double check and triple check additional help and tests to help you master this unit.
Please work the problems and take the test in your workbook. Number success, the practical way to learn.